Can somebody confirm you can hear me?
I can hear you.
Thank you. All right, before we begin, are there any questions? Let me remind you, you need to be working on your unknown project. Only some of you have gotten started. This project will take about 2 weeks, so you need to get started. Let me share my screen here. Oh, gosh, we're only 66% of the lecture being converted, so this one's going to be slowing my computer for a long time. Um, where is the screen? There it is. I was at the wrong one. On the lecture Zoom. All right. So you should be seeing my screen now. Today is November 5th. We should be talking about Lab 8, identification of gram-positive organisms. Any question about anything? On the lecture, I noticed I was supposed to actually start chapter 8 today. We only finished chapter 6, but we're probably okay because I got 2 complete days for chapter 8. Hopefully that'll be good. All right, let's go to lab 8. Are there any questions about our what we're doing? Lab 8, identification of gram-positive organisms. We're going to be talking about uh, gram-positive cocci and gram-positive bacilli. The gram-positive cocci we're going to talk about in this lab are Staphylococcus, Enterococcus, and the Streptococcus. For the gram-positive bacilli, we're going to be talking about a little bit about Listeria, Clostridium, Corynebacterium, and Bacillus. Primarily, if I remember correctly, we're going to be talking about Clostridium and Bacillus, but a little bit about the other two. There are some video clips in today's lab. We have some keys and some case studies. These last two, the key and the case studies, are provided as separate files in Canvas. Let me show you that. See how slow my computer is? Lab 7, there's the lab module, there's the worksheet, and then we have case study 1, 2, 3, 4, 5, 6. Let me scroll down to 7 and 8. 7 and 8, and then a dichotomous key. I guess I ought to look at something here. I thought about putting these all together, other than the dichotomous key, in one file, but I got these from the case studies and the individual files from our microbiology, what do you call them, the prime instructor. And I'm glad I didn't join them together because these two, he updated them and then just set them as case study 4 and case study 5. And so I was just able to easily put them in. And I decided not to join them because in the future he could change them. And I don't want them to be put in one file. And so you have to, when you're doing the case studies, you have to click on 8 different case studies. Oh, that's good. And the dichotomous key. It looks like the, uh, 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 dichotomous key. It l There it is. The Zoom lecture just finished, so that's good. My computer will now speed up. All right. Any questions about Lab 8? So like I said, sorry, there's so many different links for it, but I gotta have it this way. I'm glad I did because otherwise I'd have to redo the whole document just because one or two case studies changed. Um, Let me check something on the syllabus here. Ah, yeah, the infectious disease paper is due this Saturday, November 9th. So make sure you also finish your infectious disease paper and turn it in by 11:59 p.m. this Saturday. That will be after, no, that's next week. There will be no class on the 12th to celebrate Veterans Day. It's actually on the 11th, and I'm giving you the 12th off for the lecture. And then we'll have the unknown work, which you have to do on the 12th. We're not going to meet on the 12th, but you can work on your unknown project. Any questions about any of that? All right, let's go back to Lab 8. Upon successful completion of this lab, you should be able to, one, understand the principles and how to interpret the results for the CAMP test, the Bilasculin auger slant test, the SF broth test, and the optogen sensitivity test. We're going to talk about all of these tests today. You should be able to use a dichotomous key to solve case studies involving gram-positive bacterial infections. And let me mention that if you use this key should only be used for this lab. Do not use it for your unknown project. Do not use it for any other lab. This key is designed only for this lab. All right. When specimens are received by a microbiology lab, don't ask me why that came up. For routine bacterial cultures, they're inoculated on a culture media that facilitate the growth of common pathogens and placed in physical environments that will support their growth, meaning we put them in an incubator. Microbiologists use colony morphologies and the gram stain to provide important information about the bacterial isolates. However, further biochemical testing is required to isolate the bacterial species. In this lab, we're going to talk about the CAMP test, the Bilasculin hydrolysis test, the SF broth test, and the optogen sensitivity test. The CAMP test was invented by Christie, Atkins, and Munch Peterson, and the CAMP is just the acronym of the three microbiologists' name. C for Christie, A for Atkins, and then MP for Munch Peterson. They first described the amplified hemolytic effect that some beta hemolytic organisms have when they're physically grown near Staphylococcus aureus. You do a single streak of beta hemolytic Staphylococcus aureus down the middle of a blood agar plate, shown here. And there you can see the streak of Staphylococcus aureus. It's a dark. And then you have the clearing from beta hemolysis, which will be the clear zone around the bacteria. You then, perpendicular to the staphylococcal streak another bacteria, which is your test or your unknown organism. These bacteria should be beta hemolytic bacteria, meaning bacteria capable of performing beta hemolysis on the blood auger. So there, I have to blow it up really, really large there. You can see a single streak of Streptococcus pyogenes down the plate, perpendicular to the Staphylococcus aureus. And around the streak, we have beta hemolysis. Streptococcus pyogenes has no enhancement of the beta hemolysis near the Staphylococcus aureus growth. So this species, Streptococcus pyogenes, is negative in the CAMP test. Any question about any of that? The next we have is Listeria, which we've streaked here. And you can see the streak, it's a dark right there, and has a very thin beta hemolysis right there, most visible right there. Near the Staphylococcus aureus, we have partial enhancement of the beta hemolysis, shown right there. So Listeria has slightly positive CAMP reaction. Next, we have Streptococcus algalactia, and there's the streak of bacteria here, the dark streak. And there we can see a very thin but positive beta hemolysis around the Streptococcus algalactia. And right there, we have enhanced beta hemolysis around the strep near the Staphylococcus aureus. And this would be a CAMP positive reaction. Any question about any of that? For reasons I cannot explain, the CAMP reaction usually takes an arrow-like appearance, where the enhanced beta hemolysis forms an arrow. Any question about any of that? Even the slight one, slight CAMP, has a little bit of an arrow. Shrink that down. All right, that's the CAMP test. Any question about any of that? So normally you get an arrowhead shape in a CAMP positive test. The bile-esculin hydrolysis test is looking for the hydrolysis of bile-esculin. This test is used to differentiate Enterococcus from Streptococcus. These are two different families. If the organism hydrolyzes esculin into the product esculatin, a dark brown black precipitate will appear. So esculin broken down into esculatin, dark brown color, and in the bile-esculin slant, if we have the darkening, it's positive for the bile-esculin test. If it no darkening, it's negative, and the esculin is not broken down. Streptococcus species are negative in the bile-esculin test. Enterococcus species are positive in the bile-esculin test. To be positive, the blackening or the darkening has to be 50% of the tube or more. And that's, I don't know, a little bit more than 50%. If it's just a slight blackening, you count that as negative. And I'll never give you in your unknown test, this test where I give you one with slight. I'll either give you a clear positive or a clear negative. All right, the SF broth test was used to differentiate Enterococcus faecalis from Streptococcus faecalis, a bacterium that used to be called Streptococcus faecalis. And so the SF broth test come from the species Streptococcus faecalis, which we no longer call Streptococcus faecalis. It is now called Enterococcus faecalis, but we still call the test SF broth test. Is that clear? Sorry, that's a little confusing, but um, we used to call Enterococcus faecalis Streptococcus faecalis. And so that's why the test is called SF broth test for Streptococcus faecalis broth test. If the organism grows in the media and ferments the glucose in the media, you'll get an acid product changing the pH and the color of the media from purple to positive. So this is a negative. Either there's no bacteria in here or the bacteria cannot ferment glucose and the media will stay purple. If the bacteria can ferment glucose, the media will change to yellow, and this will be the SF broth test positive result. Streptococcus species are negative in the SF broth test. Like Streptococcus pyogenes will be purple. Enterococcus faecalis will be yellow or positive in the SF broth test. Any question about any of that? All right. So remember this name is an old name for Enterococcus faecalis when it was called Streptococcus faecalis. That's why we get the SF broth test. And this test can separate out Enterococcus faecalis from other members of Streptococcus. So it used to be called Streptococcus faecalis, and we did this test to separate it out from other Streptococcus. But now we use it to separate Enterococcus faecalis from all species of Streptococcus. All right, let's move on to the optogen sensitivity test. This test is used to differentiate Streptococcus pneumoniae from all other alpha hemolytic streptococci. So we have other Streptococcus species, which can be alpha hemolytic. And if we want to separate out Streptococcus pneumoniae from other members of the alpha hemolytic streptococcus, we then perform the optogen sensitivity test. So here we have alpha hemolytic streptococci, and we plate it on a blood agar and then put a disc containing optogen. If the bacteria are resistant to the optogen, this bacteria is not Streptococcus pneumoniae. If the bacteria has a zone of inhibition of 14 millimeters or greater, then it is sensitive to optogen and it is Streptococcus pneumoniae. Because Streptococcus pneumoniae is the only member of the Streptococcus family which is alpha hemolytic and sensitive to optogen. Any question about any of that? You do not use this test on something that's streptococci and is beta hemolytic or gamma hemolytic. You only use it on streptococci, which are alpha hemolytic. All right. Microbiologists use a dichotomous key that prescribes which tests could be performed, and then they illustrate how to arrive at a logical solution using the dichotomous logic. So in this case, we have the gram stain in all bacteria, and we have gram positive and gram negative. We're going to cross out the gram negative and only look at the gram positive. We have gram positive bacillus and gram positive cocci. We're going to cross out the bacillus and only look at the gram positive cocci. We then have catalase positive and catalase negative gram positive cocci. We're going to cross out the gram catalase negative and only look at the catalase positive. The catalase positive are members of the Staphylococcus family. We have the next test would be the coagulase test, the coagulase positive and coagulase negative. If the species is coagulase positive, it's Staphylococcus aureus. If it's coagulase negative, it's another member of the Staphylococcus family that is not Staphylococcus aureus. And then you can do the novobiocin test. If the bacteria are positive for novobiocin, shown here, it's Staphylococcus epidermidis. And if it's negative for the novobiocin test, meaning the bacteria are resistant to novobiocin, it's then Staphylococcus saprophyticus. And that's the dichotomous key. Any question about any of that? Dichotomous key, you start with all bacteria, split it into two, follow one group, split it into two, follow one group, split it into two. Follow one group, split it into two, follow one group, split it into two. And that's why it's called dichotomous logic. Now, in your unknown project, there are a few tests where you can actually split it into three. An example would be PR glucose, where you could split it into three groups: the PR glucose negative cells, the PR glucose acid producing cells, and then the third group being PR acid and gas, or AG cells. And if you split it into three, that's fine. It's still called dichotomous logic, even though you're really splitting it into three, but it's following close enough to dichotomous logic. All right, let's go to the laboratory exercises. You're not physically going to be performing any of these activities because everything we do will be done online. However, you will be held responsible for knowing how to perform and interpret the following tests. You can look at the SF broth test and the bile esculin test by watching these video clips. And then we have a video clip on the CAMP test. You should also review how to interpret the following test by completing this chart. You will need to refer to some of the previous labs as well as today's lab for finishing this chart. The first test has been done for you. For the gram stain, for both cocci and bacilli, the positive result will be purple. The cells will be purple. Remember, we're talking about the result, not the conclusion. And then the negative result, the cells will be pink. So tell me, for the Schaefer-Fulton stain, testing for endospores, what the result, positive result will be, and the negative result. And this one you'll have to get from a previous lab. And then tell me what the positive result will be for a negative stain for cell capsules, and then a negative stain for excuse me, positive result for cell capsules, and then a negative result for cell capsules. Here you can reduce the print or expand the table. You could describe it using only 3 words as well, but you might need a little description there. Give me the positive result for the catalase test, looking at hydrogen peroxide. This you'll have to get from a previous lab as well, and then the negative result. Give me the positive result for the coagulase test and the negative result. Give me the positive result for the oxidase test and the negative result. And I think all of these are from a previous lab. Here we have the positive result for the CAMP test. So discuss it. You could really only use 1 or 2 words there, but you could give a discussion. And then the negative result. Do I have that right? Yep. This one you can get from this lab. And then the biolesculin hydrolysis test, the positive result, and the negative result. Also from this lab, the SF broth test, positive result, negative result, and the optogen sensitivity test, positive result, and the negative result. These last 4 are all from this lab. If you need help on developing and using a dichotomous key, you can take a look at this video clip. It'll help you understand the general idea behind a key, and it can help you with your unknown project, but do not use this dichotomous key for your unknown project. This is only to help you. And if you're comfortable using a dichotomous key and with the concept of a dichotomous key, you do not need to view this clip. And then look at the case studies and the key, which is supplied on Canvas. I showed it to you before, to answer the questions: which bacteria species is causing the infection? All of them will be a gram-positive bacteria. So name the species for case study 1 here, for case study 2 here, for case study 3, 4, 5, 6, 7, and 8 here. And then when you have your answers, put it in the worksheet. Put your answers in the worksheet. I guess I should have shown you the worksheet. Which there's actually a change here. I've added bacitracin because you'll need the bacitracin result for one of the case studies. And then put your answers here on the worksheet. And I'm telling you that for case study 2 and 3, test 2 is the bacitracin sensitivity test. All right, any questions about Lab 8? If not, go ahead and get started on Lab 8. I will be here until 8 o'clock to help you with any questions. But I will only remain for as long as there's a student logged in. So if you have questions, make sure you log in and ask the question before all the students log out, because I'll log out once the last student has logged out. Any questions? All right, get started with the lab.